All right, hey there, folks. We're working on Monday, 3/23. I'm going to figure out this whole camera deal at some point, but for now, just bear with me. This is page 2 at 7-1, remembering problem number 1 is up here on the board. Let's solve it together. Let me fix the angle. There you go. Okay, problem number 1 says Elizabeth walks 5 blocks in 15 minutes. So I've set it up as a ratio of minutes to blocks. Of course, I could do it flip-flopped, and the answers would come out the same. But 15 to 5 is our ratio. It says she walks 30 blocks. We need to figure out what x equals. They're unknown. Set it up like cross multiplication. Multiply across the equal sign. 5 times x is 5x. 15 times 30 is 450. We know now that x is going to equal 450 divided by 5. And it gives us a nice whole number of 90 minutes or 1 hour and a half. That's how long it takes Elizabeth to walk 30 blocks. Nice job, Elizabeth. Okay, I'm going to pause. I'm going to set up problem 2, and I'll be right back. All right, so problem number 2 is asking us about a hexagonal pyramid. We're trying to find the surface area of this hexagonal pyramid. So the first thing I have to do is decode what does it mean to be a hexagonal pyramid. What the heck? Well, remember hexagon is 6-sided. Pyramid, remember, just think about ancient Egypt. Pyramids always come to a point, and the shapes that make up a pyramid or in geometry are always going to be triangles. So it's a 6-sided with triangles coming to a point. Here I've sketched it out to make more sense of it. So you can see 1, 2, 3, 4, 5 of the faces of, 4 of the faces of my pyramid. I know when I decompose this that I'm going to get 1 hexagon and 6 triangles. I can use here, this is all set up. We haven't even plugged in our numbers, our measurements, or anything. This is all just getting our thinking squared away and organized. Okay, I'm going to use this knowledge here to calculate the area of a triangle. Remember, the formula for the area of a triangle is 1/2 times base times height. And I'm going to use the hexagon, and I'm going to decompose it into triangles to find the area of that, find the area of each face, add them all together, and then we'll finally get to our answer. This one takes a couple of minutes, so just hang in there. We'll solve this one in just a second. Okay, so continuing problem number 2. I've got the base of the pyramid in blue and the faces in green. We'll start with the base. Remember, it's a hexagon. That's where the name comes from for the pyramid. We can decompose a hexagon into 6 different triangles. And the problem gives us the measurement. So 1 hexagon equals 6 of these little triangles. It tells us that the base is 14 and the distance to the center, which we can understand as the height, is 12. So we just use our formula, 1/2 times base times height for a triangle. We find the area of each of the faces is 84. But we need to multiply that by 6 because there are, right now, what I've got written in here only accounts for this one face of the triangle. I need to do these other 5 faces. So I multiply 84, and I'm going to write it like this. Area of face equals 84 times 6. And 84 times 6 is 504. That's the area of the face. Now, that's only part of it. We're halfway done. We still have to find out the area of each of the faces of the pyramid, the little guys that come up together to rise up to a point. We found the area of one triangle. We did the same thing, 14 and 20. We found the area equals 140. We need to multiply this times 4. So area of sides equals 140 times 6, and that equals 840. Now the last thing we have to do is take the area of the face and the area of the sides and add them together to find out the total. And the total added together is 1,344 inches squared of cardboard. So final answer, 1,344 inches squared. Okay, I've just got a little bit of time left. That was a really big problem, so I'm just going to show you now. I'll let you pause the video so you can check the rest of the problems on today's paper. So take a look here. We've got our fractions problems here. Find the volume, and stretch your thinking. Stretch your thinking answers may vary. Don't sweat that problem. It's a little bit of a strange one. All right, this was video 2 of 3 for Monday, 3/23. I'll post the rest later.